Yeah. Okay, so look at it. You should have typed it into your calculator, which I actually didn't, but I'm pretty sure the graph goes like this. Doesn't it? Okay, so part A says to sketch the graph. Check, we did it. Part B. Okay, when is the particle moving to the right? When is the particle moving to the left? What is this a graph of? This is a graph of V of t. Remember that if V of t is positive, the particle is moving to the right, then where would it need to be on the graph? It would need to be above the x-axis. Okay, then for my particle to be moving to the right, what would V of t need to be? Less than 0, which means that it would have to be below. Okay, so the point that you need to find then on your calculator is the x-intercept. So if you have not found that yet, go ahead and find that now. Okay, so when I graph the whole thing, it looks like this. Okay, but then I need to zoom it in, so I'm going to window it from 0 to pi. So now I know that I only want this one x-intercept right here. Okay, do we remember how to find that? Okay, it would be second trace. Option number 2 is 0. And then I can see that this is 1, 2, 3, so it's between 2 and 3. So my left bound, I'm going to type in 2. My right bound, I'm going to type in 3. You also could do the arrow option if you like that better. Yeah? Okay, enter. My x value is 2.6624. Okay, from there, what would my interval be for my graph to be above the x-axis? Which one? Are you alive? Yes. Where is it above? 0 to 2.6624. When is it below? Till infinity? Wrong. Till when? Pi. Remember that if they give you an interval, you should not extend beyond the end point of that interval. Okay, then for part C, it asks you for the velocity at pi 6th, and it asks you for the acceleration at pi 6th. Okay, now, quick question. In my graph is velocity. I want to find the y value, but if I go to my table, okay, second table, is pi over 6 going to show up in my table? No, because it's not a whole number. So remember that we learned how to find the y values. I'll show you how to do it here. You're going to need to know how to do this for your FRQ on Monday. Okay, you would do this. Ready? Alpha trace, y1, and then tell it what to plug in. So I want pi over 6. Then I want the derivative at pi over 6. I hit math 8, d dx, alpha trace y1 at pi over 6. Okay, type in both of those things. If you need help, okay, ask your little friends at your table. Okay, I bet that they can help you. Yes. In the graph, that's fine. That you just have to, if you're in the graph, it'll be the same. You have one? Oh, Colton here, this one can be for you. Perfect. Okay, so I got .5980. Okay, now real quick. Okay, can I just put this, if it's an FRQ, what do I need to label? V prime. Okay. Okay, from there, the next question says, is the speed increasing or decreasing? How do I tell that? The signs, are they the same? Yes. So my speed is increasing. Okay, a lot of y'all missed points on your test 1 and 2 because of this. What is wrong? Don't say it out loud. What is wrong with that justification? Obviously, speed is increasing is correct, but look at it for a second. Okay, be sweet, be sweet. Okay, so there are actually 2 things wrong. Oh, I didn't think about that. Okay, but she said A of t, v, slope of v of t, so that's great. What else is wrong with my justification? Yoel?
You put a number, right?
Yes, if I'm talking about a specific time, I need to say what that time is. So some of y'all put at t equals pi 6, that's fine. Okay, but I would prefer that you just pull one of these. Okay, pi over 6. Pi over 6. Okay? Yes, if you didn't put at t equals pi 6, you would have lost a point. But if you did put it, then it's okay. Okay? From here, letter E says, what is the acceleration in terms of t? That is asking you for an equation. If it says in terms of t, you need to actually take the derivative by hand. Okay, if we want the derivative in terms of t, that's going to be an equation. You'll have to actually take it. So the first thing that you should write is a of t equals what? V prime of t, and then take it. Okay, I'll give you a minute to write it first. Okay, then we can check it. V equals, this is from the equation, negative 5 cosine t, 1/2 t cubed plus 5. Now, do you notice that t cubed over 2 and 1/2 t cubed, that those are the same? Okay, it's a lot easier for me to think about the derivative like that. So what's the derivative of cosine t? It would be what? Cosine t, the derivative is negative sign, but then if there's already a negative, it's going to switch to a what? Positive 5 sine t. Okay, then for my 1/2 t cubed, the derivative would be what? Take the 3, times it down. 3 times 1/2 is 3/2 t squared. And then what about the derivative of plus 5? 0, because it's a constant. Okay? Okay, while your calculator's out, I want to check your number. I'm going to take this off and find it. It had an arctan in it. It was number... This one, 42. Has even a little star on it. Okay, number 42 says, find where what values of x where the graphs of f and y are parallel. Parallel means equal what? Slopes. So I want parallel means equal slopes, which means in the graphs I want equal what? Equal derivatives. Okay, so when I take the derivative, how will I find the derivative of inverse or arctan? Your derivative sheet. You have to look on there. It's not secant squared. That's normal tan. So pull out your derivative sheet to make sure you haven't lost it.
Inverse tan, right?
That's the same as inverse tan, correct. And it's on your sheet. It's one of your rules. Okay, you should all have one. What rule number is it? 22. I'll put it up here for you. Look. Arctan is u prime over 1 plus u squared. U prime over 1 plus u squared, right there. So, d dx of inverse tan u is u prime over 1 plus u squared. So, what is the derivative then of inverse tan 2x? It would be what? It'd be 2 over 1 plus 2x squared. Is that right? No. What is wrong with what I wrote? Parentheses. Okay, equals. What is the derivative of the e function if it's e to the 3x? E to the 3x times 3. And then how would you solve that? In the, what did I make you pick up? Calculator. Now, all of the ones with a star on it, you're allowed to use the calculator on. I don't know if you read that. It says it on the first page. Okay, but if there's a star, you can use the calculator. Or you may have to use the calculator for some of them. So, y equals, I'm typing in 2 over 1 plus 2x squared. You could also use the fraction button if you like that. It's alpha y equals. And then n over d. Okay, then on the other side I have 3e to the power of 3x. Then my graph is still zoomed in weird, so I'm going to hit zoom 6. 6 is the standard 10 by 10 window, so that I don't have to do anything weird. Okay, and actually that's so zoomed out I have to just zoom right back in. So zoom in. Now look, watch. When I hit zoom in, nothing happens. What do I still have to push? Enter, or it's not gonna know. It's not gonna actually do the action. So there's my e. There's my e graph. Second trace. I want the intersection 5. Enter, enter, enter. They cross right there. Okay. Yep. So in the calculator, I got x equals negative 0.1727. Now notice it says find the values of x. Is it possible that these cross again? Okay, let's look at our graph. I'm going to try to find an intersection over here because they get really close again, and I don't know if they cross the second time. So second trace 5. And then for my guess, enter, enter. For my guess, I'm going to move my little guy back over to the other side and see if maybe they cross one more time. Because it looks like maybe they do. Oh, is that the same one? Blast. Okay, let's move our window over and see. I'm going to make it negative 4. Just to make sure. I want to extend my window back because it looks like they cross one more time. So, second trace 5. Enter, enter, and then I'm going to go back even further. All the way back as far as I can. Because I want to make sure that they don't cross twice. Because I thought they did. Same one. Okay, I guess they only cross once. Good? Okay. Number 45, quick question. You may have not done this one yet. Okay, but it gives you 2 points, and then it asks you for f prime. What does f prime stand for? The slope. Can you find the slope when you have 2 points? Don't overthink it. This one's easy. You can. Okay, in Algebra 1 you learned how to do that. If you want f prime, the only calculus part is you have to know that means slope. And then if you have 2 points, you should be able to find the slope between them. So what would I start with? y2 minus y1 over x2 minus x1. So again, the only real calculus part of that is that f prime means slope. So I do 2 minus 7 over 2 minus negative 1. Okay, easy, easy on that one. So then 2 minus 7 is negative 5. 2 minus negative 1 is really a plus, so that'd be negative 5/3. You could also, if you like graphs better, graph it and then count the rise over run, if you like that. Okay? Okay, or graph okay. The other questions that we really kind of have to do together are the very last two. So I don't know if you've tried them, but they're both kind of hard. So we're going to do both of those together. You'll have the rest of the class to work on your own. So turn, please, to the very last page. We're going to work the bottom one on the front, then we'll work the one on the back, and then you guys will have the rest of the class to finish. Okay, so take a look, please, at number 85. Read through it, and I want you to think about literally anything that gives you a hint to do. Okay, you probably wouldn't immediately be like, oh, I know exactly what to do. But think about anything, any hints. Okay, what ideas do we have? Point of inflection, what derivative is that, first or second? So automatically on the AP test, even if you don't know what you're supposed to be doing, you should take the derivative twice, and you'll get some points along the way. So let's start with that. So y prime, and then y double prime. So do that first. Because point of inflection, we automatically know we're using the second derivative, not the first derivative. So what would my first derivative be? Okay, 3x squared plus 2ax plus b. Now what about the minus 8? Derivative is 0. Okay, from there, second derivative, what would it be? 6x plus, what's the derivative of 2ax? 2a. Now, the derivative of plus b, remember, b is a constant, so the derivative is 0. Okay, one more important thing you have to know here. Where's the point of inflection at? At 2, 0. Okay, now think about what happens at a point of inflection to the sign of this. It has to change, yeah? Now, if it changes sign, what does it have to equal at that point? 0. Okay, so one more time, think about it. For a point of inflection to happen here, what does y double prime have to equal? 0. When does it have to happen? At 2. Is that enough for you to find A? Yes. So, find A for me. Okay, so we know two things in case you didn't understand that. We know that the second derivative, f double prime, changes sign at x equals 2, which means that f double prime must equal 0 at x equals 2. Okay, so if it's going to change sign, it has to equal 0. So we're going to set this equal to 0. We're going to plug in 2. And then automatically, pretty much, you can find A. So 2 times 6 is 12. Bring it across, then it's a negative 12 equals 2A. What does A have to be? Negative 6. Okay, so we have A, but they asked us to find B. Now, you get partial credit for finding A. But think about, what else do we know besides that there's a point of inflection? We also were given the entire point. Where do you plug in points? To y double prime, y prime, or the original? The original. So go back to the original, right here. Now you know three things. You know that x is 2, you know that y is 0, and you know that A is what? Negative 6. What's the only letter that's going to be unknown? E. So now you can find B. Okay? So remember, for a point, you are always going back to the original. Okay, so I'm plugging that in now here. My y is going to be 0 equals. Then this would be 2 cubed minus 6, 2 squared, plus b times 2 minus 8. So my x is 2, my y is 0, and a is negative 6. Those are the things that we already know. Kelly? Okay, 2 cubed is how many? 8. Then 2 squared here is 4 times 6 is minus 24. That'd be a 2b. And then a minus 8. What happens with 8 and negative 8? They do what? Gone? Then I'm going to take my minus 24 across. That will turn it back to a positive 24. And if 24 is 2b, then what's b? Then b is 12. Good. Okay, so for part A, we found A, we found B, we're done. Okay, part B says, for which values of x is the function increasing at an increasing rate? They're giving you signs for the first and the second derivative. What do they both have to be? Positive and positive. So you're going to do a first and a second derivative test, and you're going to find the intervals where the graph is positive. Now remember, we know A and B now. So I'm going to come back to my y prime here. What am I going to plug in for A? What am I going to plug in for B? 12. So let's do that first. So I know here that f prime has to be greater than 0 and f double prime has to be greater than 0. So I'm going to find the intervals where that happens. Let's do f prime first. So y prime is here. It's going to be 3x squared plus 2 times negative 6x plus 12. That should be a y prime. I labeled that wrong. And then how do I do a line test on it? I set it equal to 0. So I have 3x squared minus 12x plus 12. Okay, factor that, do your line test. Factor that, and then do your line test. So what can I take out before I try to break it down? All those can divide by what? 3? That gives me x squared minus 4x plus 4. And what's the only number that will times to 4 and also add to 4? And it'd be x minus 2 squared, right? So what's my critical number? What's going to make it 0? X equals 2. And then I'm going to make my line chart here. 2 is my number. But then think about if x minus 2 is squared, what does that always have to be? Positive and positive. So that means that my graph is always increasing. Okay, now let's find at an increasing rate. That's the second derivative. So my f double prime is right here. I'm only plugging in my a, which is a negative 6. So then y double prime has to be 6x plus 2 times negative 6, which is 6x minus 12. Take out your 6. What's left over? X minus 2. My critical number is 2. Set up your line chart underneath the old line chart. 2 is the exact same x value, but this one's going to change sign because it's not squared. If I plug in 0, what's 0 minus 2? Positive or negative? Negative. Plug in 3. 3 minus 2 is positive. So my graph is concave down, then it's concave up. So now looking at your double line chart, when is it increasing at an increasing rate? From where to where? To infinity, because it's increasing and its second derivative is also positive. Make sense? Okay, so it would be from 2 to infinity. Also remember that they could put x greater than 2. That would be the same. So you should know both of those. Okay? Alright, turn over to the back. I want you to kind of do the same thing. I'm going to give you a couple seconds. I'm going to bring you a cookie. And I want you to do anything that you can think to do on the next question. Okay, since this is calculus, you probably know a derivative will be involved, right? So read through it, think about anything like that one we just did that might give you a hint at what to do. And you can work with other people too. Sean, you want a cookie? Yeah, are we working on it?
No, I'm not sure. Just do it like 9 p.m.
But you know this is a test for you. I love asking you every day. I know, I love that. Just to make sure.
But yeah, you want to
Did you put your goals and everything on there? The revision sheet, you saw that in? This one, the revision sheet, that was separate grade.
I will warn you that a lot of my procrastinators might be in here.
I think the revision sheet just has to sell.
And honestly, calculus procrastinators are more important to me than algebra procrastinators. So if I am not able to, I would say let's just.
You gotta respect his effort, though.
Honestly, like all of this.
You're doing way better than me, but
I will help you on my part.
I need to know my grade.
I will be annoyed and frustrated because I'm dealing with photos. So why don't we just have a special lunch meeting? You come in today, that's a good ready to slap some kids, and I don't want to do something.
So you had 80 left?
What lunch do you interested in? I mean, you're welcome to come in, but I just had a bunch of kids today. Literally, I'm gonna come in your lunch, and I'm just gonna open my chest, and I actually don't even know how to act. You're not good for that. You're supposed to be starting the last one, and I'm going to end up giving you a hint, but I want you to try to do something before I help you. Okay? Fulton, how's number 86 coming? I see you wrote your name instead of doing any math. Did you turn in your job sheet already?
I was doing homework, I was like, everybody.
Can you get it up so we can at least accomplish one thing today?
No, there's people I found like, how do you I don't know. I was like,
No one knows. You're gonna have to find out. You don't like
I am determined. Initial positions.
That's the position. Okay, you are working on homework, and you could be working on a test.
I literally just said like 30
Does that seem smart? To work on a piddly homework that will be worth less than 1% of your final grade. When you have a test grade on your desk and half finished, you're going to get 100 on a homework that's for partial credit because it's so late, and you're going to not finish your test. I'm just asking, not throwing any shade.
No, not at all. Not at all.
I think that's like the most I've ever seen.
Party.
Hey, but you're surrounded by
Oh no.
most of y'all aren't really real nerds.
Okay, I'll sign it in a minute.
Okay, what did you do? Let's think about it. Hey, good. Okay, so listen, what Yoel said is perfect. He took the derivative, and then what did it say the slope is? Now, when is it 5 at? Yes. Okay, so you need to set the derivative equal to 5 at x equals 1. So the derivative up here, y prime, would be 3c x squared minus 4x plus 3. We're setting it equal to 5 when x is 1. So that would be 3 times c times 1 squared minus 4 times 1 plus 3. So 5 is 3c. What is negative 4 plus 3? Okay, then I add my 1 across. 3c equals what? 6. Which means that c equals 2. Did anybody get there? Whoop whoop. Okay. Now, one other interesting point is that they gave you a point. Where do you use points? Not the derivative, but the original. So what should you do with your point? You should go back to the original, plug it in. Now that you know c is 2, the only thing you won't know will be what? A. A. Good. Get it? Okay, so here we go. Our point is 1 comma a plus 1, but I'm going to use it in the original. So I would let a plus 1 is my y value equal. And then when I come back to the original, my c is now a 2. My x cubed is a 1 cubed. Minus 2 times 1 squared plus 3 times 1. Okay, from there, I know that a plus 1 equals 2 times 1 is 2, minus 2 plus 3. What's 2 minus 2, though? So a plus 1 is 3, then a equals what? 2. Okay, now, we have a lot of stuff. You would have gotten a lot of points if this was an FRQ, but you haven't actually answered the question yet. So it says, find the values of C and A, check. Okay, so that blah, 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 point, blah, blah, blah. Okay, here. Find where the tangent, what do we need to write? Tangent line. Okay, find where the tangent meets the curve. So let's start with the tangent line. What 2 things do I need for a tangent line? Okay, a point and a slope. So let's start with that. Do I have the point? Okay, now it's 1 comma a plus 1, but now what's a? 2. So it's 1 comma 3. Okay, so bloop, plug it in. My point is 1 comma 3. And what is my slope? It was already given to you. 5. So given those 2 pieces, can I write the equation of my tangent line? It'd be y minus 3, 5x minus 1. Now, I want you, this is a hint I'm going to give you, solve it for y. So I'll give you a minute to do that. Okay, but we're not going to be able to do anything with it in point slope form. We need to solve it for y equals. So my first step is I'm going to distribute the 5, and then I'm going to add the 3 across. So it would be y equals, or y minus 3 equals, 5x minus 5, then add the 3. So 5x minus 2. That's my equation of my tangent line. Now, what does it say I want my graph to do? It says that I want my tangent line and my curve to meet. What does that mean I want them to do? Intersect. Now, you're going to need a calculator for this. This was a calculator question. So, if I want to know where they intersect, I'm going to graph this, graph the original, and then find where they cross. So, do that now for me, please. So, this is going to be my y1. My y2 is going to be the original, which is c is 2x cubed minus 2x squared plus 3x. And then I'm going to find where they cross. Now, I want you to pay attention to a detail. It says, find where the tangent meets the curve again. How many times do we know they cross? Twice. Once, where do they cross at? 1, 3. That's the one that you already have. You need to find the other one. Okay? So when you graph it, you're going to end up with a cubic like this. And then you're going to end up with a line like this. And so they cross twice. This is the 1, 3 that we already have. You need to find this one. Okay? So you need to find where they meet again, meaning not the original point, but the new point. And it should have a negative x value and a negative y value. You can do it. What did you do that you're not feeling good? At least your uterus works, you know. Pros and cons. So.
What are we talking about?
She said she was cramping. I was trying to look on the bright side, you know.
Oh.
Thank you.
Yeah.
Not if that's happening. Then you're not. What is it? Did you find it?
-1.
Yeah. Yay! Good job. It's the original equation, but I just plugged in C is 2. Yeah? So this is the original curve. I just plugged in that now I know. This is the original, and then this is the tangent line. And then it says that I want original curve, and then this is the tangent line. So if I want them to meet, I'm just looking for where they cross. Okay, you have 10 minutes left. Now, one more thing that I forgot about that I need to tell you. Okay, do you guys remember that PVA practice that we did long ago? Oh, Kelly, this is yours. Where's Kelly? You left this in here, though. Okay, your PVA practice, I'm going to count it for extra credit if you do it. I'm not going to count it as a homework because I forgot about it. Okay, so this right here.
The one that we trained a while ago?
No, so listen, you've had now 2 practices. The one practice was when I was gone with the sub. It had all the E and LNs. That was for a grade. You should have already turned it in. Okay, but this particular homework I forgot about, and so you probably forgot about it. So this will be extra credit. If you'd like to do it, great. It will be due just by Monday. Okay, where should I add it?
By the time I read this one,
Final? Okay, it's kind of long. So I'm going to add it to your exam grade. We'll do 7.
I have a chance now.
Did you say you have a chance at getting the 40?
I have a chance. I can't get the 40 then.
You need 40 points? You have a 30 as your average?
In this class.
Ooh, Marcel. Huh?
I don't want to hear about 19. Let's go.
Oh my god.
Okay, it's not a contest to get the lowest grade. This is not golf, guys.
When I told
You want the highest grade.
when I told her I got 69 in this class, she goes,